Today we are going to talk about electron configuration. What is electron configuration? It's the distribution of electrons in energy levels. But first, let's revise what we've learned before about matter and the atom. Matter is everything around us. Everything around us is matter. And the building units of matter are atoms. Atoms are so tiny, you cannot see atoms with your eyes. But how did we learn about atoms if we cannot see them? Chemists, the scientists who study chemistry and study matter, concluded by thinking that they exist, atoms exist, when they carried out experiments and chemical reactions. Now let's zoom in within the atom. The atom has subatomic particles. Subatomic means within the atom. These subatomic particles are protons. They are within the nucleus. They carry positive charge. Also within the nucleus are neutrons. Neutrons are neutral. They have no charge. Electrons carry negative charge and they orbit the nucleus in energy levels. What are the forces within the atom? There are fundamental forces, means forces which we find in nature. They exist within the atoms of matter. The forces which are within the atom are electromagnetic forces and nuclear forces. Electromagnetic forces means electric forces, and nuclear means a force within the nucleus. Let's understand the electric forces and how they work. Protons are particles that carry a positive charge, and electrons are particles, يعني جسيمات. They carry negative electric charges. There is a rule within electric forces that the similar, means same, electric charges repel each other, means they push each other away, while opposite electric charges attract each other. So protons repel each other, push each other away. Electrons push each other away, but a proton and electron, they are of opposite charges and therefore they attract each other or move towards each other. Now, what are the forces which act inside the nucleus? There is repulsion. Repulsion means that the protons push each other away. There is repulsion between the protons. But the nuclear forces in the nucleus keep the protons and neutrons together. So the repulsion between, which is an electrostatic force between the protons, push them away from each other, but the attractive nuclear force, which is strong and keep every particle within the nucleus together. So this drawing explains the same. The repulsion between the protons pushes them away, but the nuclear force keeps the neutrons and protons together because it is an attractive force. There is repulsion between the electrons which surround the nucleus. but the nucleus attracts the electrons, and therefore they are held in their energy levels. So that's why the atom is stable. Electrons stay in energy levels because they are attracted towards the positively charged nucleus. And all of these forces keep the atom stable, and the electron configuration is placing the electrons in the energy levels within the atom. They follow certain rules. Let's examine some atoms. Let's start with hydrogen. Hydrogen is the smallest element in the universe. Hydrogen has one proton and one electron. The proton is in the nucleus, and the electron is in an energy level orbiting the nucleus, and it is near the nucleus, not very far from it. Helium is a gas, it's also in the air. Helium, the nucleus of the helium atom has two protons, and it has also two neutrons. Two protons, two neutrons. And there are two electrons, and the two electrons orbit the nucleus, and they are in the same energy level. In the same energy level means they have the same energy. Okay, now let's examine lithium. Lithium is a metallic element which is found in the earth. يعني عنصر معدني موجود في الأرض. Now, you might have heard about lithium-ion batteries. They use lithium in them. If we examine a lithium atom, we will find that it has 3 protons and 4 neutrons in the nucleus. 3 protons and 4 neutrons. And it has 3 electrons orbiting the nucleus. The first 2 electrons are in the same energy level. Now, by this, the energy level is complete. It cannot have any more electrons. Therefore, the third electron goes into a second energy level farther away from the nucleus. Let me explain this in an easy way and in Arabic. الثلاث الكترونات ما تقدرش تفضل موجودة في نفس الانرجي ليفل علشان بينها repulsion، بينها تنافر. Therefore, the energy level can take only 2 electrons, and the third electron goes into the next energy level farther away، أبعد قليلا عن النيوكليوس، عن النواة. Now we are going to talk about an element called beryllium. Beryllium is another metallic element found in the earth. Beryllium has 4 protons and 5 neutrons, and all of these are in the nucleus. Since it has 4 protons, it also has 4 electrons. The electrons orbit the nucleus, and they are found in 2 energy levels. The first energy level takes 2 electrons only, and it is complete. And the next 2 electrons go to the next energy level. So 2 in the first energy level near the nucleus, and 2 electrons in the next energy level a little bit farther than the nucleus, in order for the atom to stay stable. Boron, another element. Boron has 5 electrons, Again, it has 5 protons and it has 5 electrons. 2 electrons are put inside the first energy level. The 3 electrons, 5 minus 2 is 3. The 3 electrons are in the next energy level. First energy level has 2 electrons. Second energy level has 3 electrons. And therefore, the electron configuration is 2, 3. Now carbon. You know carbon as coal. الفحم مكون من الكربون. Carbon atom has 6 electrons because it has 6 protons in the nucleus and 6 electrons in the energy levels. The 6 electrons are in 2 energy levels. The first is complete with only 2 electrons, and the 4 electrons are placed in the next energy level. That's why we say that the electron configuration is 2, 4 means 2 in the first energy level and 4 in the second energy level. First energy level is the nearest to the nucleus, and the second one is further than the nucleus. Now nitrogen. Nitrogen has 7 electrons because it has 7 electrons, 7 protons, and 7 neutrons. The 7 electrons are distributed in 2 energy levels. The first takes 2 electrons, and the 5 electrons goes to the second energy level. So the electron distribution or configuration is 2, 5. Now oxygen. Oxygen is the gas which we breathe. It is in the air. Oxygen atom has 8 protons and 8 electrons. The 8 electrons are distributed in 2 energy levels because remember the first energy level only takes 2 electrons and the 6 electrons go to the next energy level. So it is 2, 6. Let's examine fluorine. Fluorine is an element which has 9 electrons in 2 energy levels. The first one nearest to the nucleus has 2 electrons, 1, 2. That's the first energy level. There are 7 electrons placed in the second energy level, 1, 2, 3, 4, 5, 6, 7. So the electron configuration of fluorine is 2, 7. This is neon. Neon is a gas. Neon is also in the neon lamp. Neon has 10 electrons. The 10 electrons are in 2 energy levels. The first one has 2. It is complete. And the next 8 electrons are placed in the next energy level. And therefore the electron configuration of neon is 2, 8. Now we will examine sodium. Sodium is a metallic element. Now this is sodium atom. It has 11 protons, 12 neutrons, and 11 electrons. The 11 electrons are distributed in 3 energy levels. The first energy level has 2 electrons. It is full, complete, saturated. So now 8 electrons go to the next energy level and it is saturated or complete or filled. طيب, what about the last electron? It goes to the third energy level because the energy level 2 can only take 8 electrons.